As Erdy said, I am by day a infrastructure engineer, and I am not going to talk about that at all. Instead, I'm going to talk about that time I set out to build myself the perfect keyboard. And if you've looked at the title of my talk, you know that I failed. Why? Easy. Hubris. So this started with DSA Dark Magical Girl, which is a set of keycaps that I found online one day, and a friend of me encouraged me to buy, and I absolutely fell in love with. But unfortunately, these are key caps, not a keyboard, and you need a board to put them on. And unfortunately, this was the keyboard that I used at the time, which is, it was suiting me very well, but it wasn't fancy. It wasn't cool enough. So I spent a bunch of time researching keyboards, which is one of those holes that you can basically dig forever in, and I discovered this thing. This is the ErgoDox Infinity, and it had a bunch of features that I liked. It was split, it had USB-C, it had these cool little screens in the top that you could do cool things with, but it was missing a couple things. It didn't have the RGB that I wanted, and the connector was on the right-hand side instead of the left, and since I'm right-handed, I wanted to be able to only have the left-hand side so I could play video games. But it did have one feature that was really the beginning and the end for me. It was open source. So plenty of people have already talked about what I learned today is pronounced KiCad and not KiCad. But the way it basically works is you have this symbolic representation, and then once you've got that, you can physically lay everything out on the board, and you can only kind of see it. These lines are called the rat's nest because you need to play this game a whole bunch and figure out how to connect everything together, and eventually you get something that looks like this. And this is real. This is from the board that I partially created. Usually when you are adding those gamer ergobleds to a keyboard or anything else, you use these. They're called WS2812s or NeoPixels if you're feeling fancy. And the way that they work is, if you've ever seen a long strip, the way that works is that they pass data along from one to the other, which makes them very, very easy to connect because you need to put power in from one, power out to another, data in, data out, you make a long string, it works great. I decided for whatever reason that I was going to do this instead, which is a bunch of individual LEDs, all of which need 4 wires going to them. And this is fine if you have a matrix, but is with nothing else, but is kind of a pain in the butt if you have, for example, got a bunch of keyboard switches and stuff in the way that you need to route around. But I did do this. And then I got this lovely email from the people at the PCB company who were just like, hey, so you used the wrong settings when you were designing this board. Because it turns out in KiCad, you need to very carefully add, this is how much my PCB manufacturer can drill. This is how big these lines can be. And if you were, for example, to just sort of assume naively that all of these numbers would always be the same, you might have to start your entire keyboard over again and reroute all of the lines again. But these beautiful boards did eventually arrive, and they have I paid extra for the little stencil on the back, which is very cool and helpful for soldering. But this is, you can see these little blue squares at the top. One's labeled D-, one's labeled D+. These are resistors. And when you're zoomed in like this, like you are at a computer, this looks like a totally doable thing to do. But when you actually get them, they look like this. And if I zoom out a little bit, this is a micro SD card, and I took this photo with my USB microscope. So this is the size of component that I'm working with. This is my picture, by the way, because I did do this. And this is what surface mount soldering is supposed to be. You can't use like an actual like soldering gun stick thing. And you see how they automatically sort of align themselves and like surface tension pulls them into place and it looks really magical? That doesn't actually happen in real life if you don't know what you're doing. So, and even better, you can only use the stencil once because it requires the board to be flat. Once you have added all of those components to the board, you can't use the stencil anymore, so it doesn't fit. So you just have to sort of unsolder the chip very carefully and then like put it back on and like try to get it into the right place. People make this look very easy, and it very, very much isn't. Even better, this is the LED driver, and are those pins on the side connected? I don't know. Do you know? So this was honestly a high watermark. I don't think I ever got this many LEDs working together again. And eventually, I went all through this list of things that might possibly be wrong. I have this cool setup where I felt like a cool hacker because I had like a Raspberry Pi for the serial, and I had like the programmer for debugging, and I had the logic analyzer for the I²C, and there's like a bottle of rubbing alcohol, and it looked very cool, but it didn't work, and eventually I gave up. By which I mean, of course, I started over. So this is a STM32 Nucleo, which is a development board for a STM32. It is pre-soldered, which was a very big deal for me. It has a built-in programmer, so I don't need to add my own sockets. It was an STM32, and importantly, the chip on it was available because this was the height of the chip crisis. Did you know that people scalped microcontrollers? And STM32 was really important because I wanted to write a new firmware for this keyboard in Rust. And if you don't know why I wanted to write it in Rust, you clearly haven't talked to any Rust programmers. By the way, this is Hubris, the concept, not Hubris, the Rust real-time operating system written by Oxide. But if you work for Oxide on... Call me. It didn't have a USB port, but that's okay. The pins for it were broken out, and so I could connect them properly. And here I am using one computer on the left as the USB device and one computer on the right to actually program the USB device. This was deep in me trying to write my own USB driver because the library that I was using didn't actually have one for this particular chipset. What about my RGB? Well, I bought one of these from Adafruit, and it is pre-soldered, my new favorite thing in the world, and I could plug it in and program it and make sure that the problem was my code and not the device itself, plus I can make pretty rainbows. And eventually I could connect that code that I now knew worked to this board and discover that maybe I shouldn't have just assumed all of the LEDs that I bought for $10 off AliExpress worked perfectly the first time. This is what I call the depth-first engineering approach. I discover something, and I just sort of work my way down deeper and deeper and deeper until there's nobody in the world who could possibly assist me with anything else. This list literally does stop because at a certain point, Google Slides won't let you indent any farther. So what I basically learned is that you should not write everything all at once. You should prototype things. Prototype, 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 which basically means I reinvented not doing waterfall programming for myself from first principles. And I completely overshot getting into keyboards, which normally for most people means, oh, maybe I will take these switches apart and I will oil them, or maybe I will buy a new keyboard. And I was like, maybe instead, I will learn how to write drivers for a real-time operating system so that maybe eventually I can have a keyboard. And in the end, you know what I did? I bought a commercial one because I needed a keyboard and I got a stipend from a new job. There is a more detailed write-up of some of the earlier steps on this on my blog, blog.stillinbeta.com. Co-host is where you can find me. That is my email address. That is my Mastodon. And if you are a professional colleague and you are seeing all of this social media that I don't talk about at work, no, you didn't. Have a good one.